brown Decora slide dimmers from Lutron are no longer available for purchase, having been discontinued. However, several alternative options can be considered. Firstly, Lutron still offers brown Decora rotary dimmers that share a similar style to the discontinued slide dimmers. These rotary dimmers could provide a readily available alternative while maintaining a cohesive aesthetic. Secondly, used or vintage brown Decora slide dimmers might be found online through platforms such as eBay or Craigslist. This approach allows for matching existing devices, but these vintage dimmers may be difficult to locate and may not be in perfect condition. Thirdly, some electrical contractors may be able to create custom brown Decora slide dimmers using compatible parts. This option could precisely match the desired style and functionality, but may be costly and time-consuming. When seeking to match existing brown Decora slide dimmers, purchasing used or vintage ones presents the most reliable way to achieve an exact match. However, it is crucial to acknowledge the potential challenges in finding these dimmers and the possibility of imperfections due to their age. When selecting any alternative dimmer, ensure compatibility with the existing electrical system and lighting fixtures. The brown Decora slide dimmers possess a distinctive style. If maintaining a similar aesthetic is a priority, consider brown Decora rotary dimmers or custom dimmers specifically designed to match the original slide dimmers. Rotary dimmers operate somewhat differently than slide dimmers. Adjusting to the new controls might require some time if you are not familiar with rotary dimmers. When dealing with electrical components, several fundamental concepts are crucial to understand. Voltage, measured in volts, represents the electrical potential difference that drives current through a circuit. Amperage, measured in amps, quantifies the amount of electrical current flowing. Resistance, measured in ohms, opposes the flow of current. These three parameters are interconnected by Ohm's law, which states that voltage equals current times resistance. Understanding wire gauges is also essential for safe and efficient electrical work. Wire gauge refers to the physical size of the wire, and it is inversely related to the wire's current carrying capacity. Larger gauge wires can safely handle higher currents. The National Electrical Code, or NEC, provides guidelines for selecting appropriate wire gauges based on the expected current load and application. For example, NEC Table 310.15b16 specifies the allowable ampacities of insulated conductors rated up to 2000 volts, 60 degrees Celsius through 90 degrees Celsius, not more than 3 current-carrying conductors in a raceway or cable or earth directly buried, based on ambient temperature of 30 degrees Celsius. When working with electrical circuits, various protective devices are used to prevent overcurrents and ensure safety. Circuit breakers and fuses are designed to interrupt the flow of current when it exceeds a predetermined level. Ground fault circuit interrupters, or GFCIs, are used in locations where there is a high risk of electric shock, such as bathrooms and kitchens. GFCIs detect even small imbalances in current and quickly trip the circuit to prevent injury. Electrical boxes are enclosures used to house electrical connections and protect them from damage. Different types of electrical boxes are available for various applications, including wall boxes, ceiling boxes, and junction boxes. Conduit is a protective tubing used to encase electrical wiring. Metal and non-metallic conduit options exist, each offering different levels of protection and suitability for specific environments. When installing electrical wiring, proper grounding is crucial for safety. Grounding provides a low-resistance path for fault currents to flow back to the source, minimizing the risk of electric shock. Grounding electrodes, such as ground rods or metal water pipes, are used to establish a connection to the earth. The electrical outlets, also known as receptacles, provide a convenient way to connect electrical devices to the power supply. Standard outlets are rated for 120 volts, while some appliances require 240-volt outlets. When replacing electrical outlets, it is important to ensure that the new outlet is compatible with the existing wiring and meets all applicable safety standards. Electrical switches are used to control the flow of current to lighting fixtures and other devices. Single-pole switches control a circuit from one location, while three-way switches allow control from two locations. Four-way switches enable control from 3 or more locations. When selecting electrical switches, consider the amperage rating and the type of load being controlled. When working with electrical wiring, it is essential to use appropriate wire connectors to ensure secure and reliable connections. Wire connectors, such as wire nuts and crimp connectors, are designed to join wires of the same or different gauges. Proper use of wire connectors is crucial to prevent loose connections, which can lead to overheating and electrical fires. Electrical tape is used to insulate and protect electrical connections. It is important to use high-quality electrical tape that is rated for the voltage and temperature of the application. Electrical tape should be applied in overlapping layers to ensure complete insulation. When working with electrical circuits, it is crucial to follow all applicable safety precautions. Always turn off the power to the circuit before working on it. Use insulated tools to prevent electric shock. Wear appropriate personal protective equipment, such as safety glasses and gloves. If you are not comfortable working with electricity, consult a qualified electrician. Electrical codes and regulations vary depending on the location. It is important to be familiar with the applicable codes and regulations before undertaking any electrical work. The NEC is a widely adopted electrical code that provides guidelines for safe electrical installations. Local codes may have additional requirements or modifications to the NEC. Proper planning is essential for any electrical project. Before starting work, create a detailed plan that outlines the scope of the project, the materials needed, and the steps involved. This will help to ensure that the project is completed safely and efficiently. When working with electrical wiring, it is important to label all circuits and connections. This will make it easier to troubleshoot problems in the future. Use a permanent marker or label maker to create clear and accurate labels. After completing any electrical work, thoroughly test the circuits to ensure that they are functioning properly. Use a multimeter to check voltage, current, and resistance. If you encounter any problems, consult a qualified electrician. Regular maintenance is essential to ensure the continued safety and reliability of electrical systems. Inspect wiring and connections periodically for signs of damage or wear. Replace any worn or damaged components promptly. Keep electrical panels and equipment clean and free of dust and debris. When troubleshooting electrical problems, start by checking the simplest things first. Make sure that the power is turned on and that all switches are in the correct position. Check for tripped circuit breakers or blown fuses. Use a multimeter to test for voltage and continuity. If you are unable to identify the problem, consult a qualified electrician. Electrical emergencies could occur at any time. It is important to know what to do in the event of an electrical fire or shock. If someone is being shocked, immediately turn off the power at the source. Do not touch the person until the power is off. Call emergency services and provide them with as much information as possible. Electrical safety is everyone's responsibility. By following safe work practices and taking precautions, you can help to prevent electrical accidents and injuries. If you're unsure about any aspect of electrical work, consult a qualified electrician. Remember to always prioritize safety when working with electricity. Understanding basic electrical concepts such as voltage, amperage, and resistance is essential for anyone working with electrical systems. Ohm's law provides a fundamental relationship between these three parameters, allowing you to calculate voltage, current, or resistance if you know the other two values. Wire gauge is another important concept to understand. The wire gauge determines the current carrying capacity of the wire, and it is important to select the appropriate wire gauge for the application to prevent overheating and electrical fires. Protective devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overcurrents. These devices interrupt the flow of current when it exceeds a predetermined level, preventing damage to equipment and reducing the risk of electrical fires. Ground fault circuit interrupters, or GFCIs, are used to protect people from electric shock. GFCIs detect even small imbalances in current and quickly trip the circuit to prevent injury. Electrical boxes and conduit are used to protect electrical wiring and connections from damage. Different types of electrical boxes and conduits are available for various applications, and it is important to select the appropriate type for the environment. Grounding is an essential safety measure that provides a low resistance path for fault currents to flow back to the source. Proper grounding minimizes the risk of electric shock and helps to prevent damage to equipment. The electrical outlets and switches are used to connect electrical devices to the power supply and control the flow of current to lighting fixtures and other devices. It is important to select outlets and switches that are rated for the voltage and current of the application. Wire connectors and electrical tape are used to make secure and insulated connections between wires. Proper use of these materials is crucial to prevent loose connections, which can lead to overheating and electrical fires. When working with electrical systems, it is essential to follow all applicable safety precautions. Always turn off the power to the circuit before working on it, use insulated tools, and wear appropriate personal protective equipment. If you are not comfortable working with electricity, consult a qualified electrician. Electrical codes and regulations vary depending on the location, and it is important to be familiar with the applicable codes and regulations before undertaking any electrical work. Proper planning, labeling, and testing are essential for any electrical project. These steps will help to ensure that the project is completed safely and efficiently. Regular maintenance and troubleshooting are important for ensuring the continued safety and reliability of electrical systems. Inspect wiring and connections periodically for signs of damage or wear, and troubleshoot any problems promptly. In the event of an electrical emergency, it is important to know what to do. Immediately turn off the power at the source if someone is being shocked, and call emergency services. Electrical safety is everyone's responsibility, and by following safe work practices and taking precautions, you can help to prevent electrical accidents and injuries.